Hi, Calculus 1 students. So this exercise, it's an exercise that you can do. It relies on a similar problem that we have done together in the section 3.1, although this time the algebra is harder. But I just want to bring your attention to that point. The algebra is harder, which means that it's not calculus. Like the calculus part is to use the product rule. That part is easy. Well, in this case, it's actually the quotient rule. But that's it. You should be able to do it on your own. Okay, so give it a good try. And if it doesn't work, then YouTube video is here for you. So if the line y equals 3x minus 1 is tangent to the curve f of x equals ax over x plus b at x equals 1, find a and b. So first of all, you should note where a and b are. Okay, so a and b are the parameters like that are here. Okay, so they define the function. Okay, so we have like a class of function here, and each value of a and b will define like one of these functions. That's the way it works. Okay, so how do we do this? We're gonna use two arguments. The first argument that we're going to use is the one that the slope of the tangent line at x f of x, so in other words, the derivative, must be equal to 3, which is the slope of this line, because this line is tangent to the curve. Okay? So that's the first argument. So, so the slope at x f of x, okay, must match the slope of y equals 3x minus 1, okay? And this is really because this line is tangent. And notice that the slope in this case is 3. So, right, you're just looking at the number that's right up here. Okay, so this 3 right here, this is what we're talking about. So what does it mean? It means that you're going to perform the derivative of this function. So f prime of x. And this is the quotient rule. Now, again, the quotient rule, as you get comfortable with it, you can go really, really fast. I'm going to go slower than what I'm expecting out of you guys, just so that you can see what's going on. So the quotient rule, so you take the derivative of the top, you multiply by the bottom, okay, minus the top times the derivative of the bottom. There you go. And divided by the bottom squared. That's how you write the quotient rule. Now, each derivative is is easy to perform. So you have a for the first one times x plus b minus ax. And I will say here for the sake of it times 1, right? The derivative of this is 1. And this is divided by x plus b squared, okay? Before anything else, let's simplify this formula. I hope I can write it here, like x plus b squared, okay? Because what I want you to notice is that it turns out, and this is just chance, well, this is just luck, pretty much, that this a times x is canceling that a times x, but you still need to distribute. So at the top, you will get here a times b over x plus b squared. Okay, so that's the first step. The second argument is that at the point of tangency, the values of y should match, right? So the y coordinates oh, and I forgot to do something actually. Oh, yes. Okay, sorry about that. I'm just going to erase this. So one thing that I forgot to do is to use the at x equals 1. So I'm going to color code this, let's say in green. Okay, so the at x equals 1 is important here because it's not always true that the derivative is equal to 3. It's true only at x equals 1. So, so here I have to correct this. It's not x f of x, it's 1 f of 1. And this is a really important correction. Okay, so the first step doesn't change. You still do the derivative, but then after that, you have to, so the slope at 1 f of 1 turns out to be f prime of 1. So now what you're going to do is you're going to replace, so f prime of 1 is just going to be this formula for which you plug in 1. So a times b divided by 1 plus b squared. All right, second step. Now we're done the first step. The second step is what I just told about, that at x equals 1, the y coordinates needs to match. So the y coordinates of f of x and y equals 3x minus 1 must match, but again, at x equals 1. So what does it mean? It means that, oh, and something I forgot to say here is, okay, well, this slope that we have over here must equal to 3, right? So there you go. So now let's go back to number 2. Okay, so the y coordinates of f of x must match at x equals 1. So what does it mean? It means that you're going to have f of 1. And f of 1, there's not much you can do. You're just going to replace in this formula. So it's going to be a times 1 divided by 1 plus b. Okay, so in other words, a over 1 plus b. And then y of 1, let's put it this way, right? This is like okay notation. That's going to be 3 times 1 minus 1. So in other words, it's going to be 2. So what does it mean? It means that we have a second equation. It means that a over 1 plus b is equal to 2. All right, now let's erase the first step, like the derivative step. And what I want to do is to write down these two equations so that we can solve them. So bye-bye derivative. So what we mean is we want to solve the system. So solve system. So AB over 1 plus b squared is equal to 3. And the other equation is A over 1 plus b is equal to 2. Okay. Now, obviously, there's more than one way to solve this. Like, this is where the algebra can get really tedious if you're not careful. So, one thing I will do, I think, is I will solve for 1 plus b. Okay, so I'm going to have here first that 1 plus b, or no, I think it's not the right way. Oh, yeah, I'm going to solve this one for a and substitute in the other. I think it's the best way to do it. So, all right, we're going to have a that's equal to twice 1 plus b. So this means that you can replace this a over here. Let's do it, let's say, in red. So we're going to have here in this equation twice 1 plus b over 1 plus b squared is equal to 3. Okay. Now it's the time to erase everything else. Now we're going to focus on these two equations. And here there's a little bit of danger of doing a step that is not algebraically justified. So what's happening if b is equal to -1, that would make this 0. Well, if b is equal to -1, it means that the function is undefined at 1. Okay, so we're safe. B cannot be -1. So we can actually just go ahead and 2 over 1 plus b. Actually, this is valid even if if b was equal. Well, b can't be equal to -1. Otherwise, we would not have got these equations in the first place. Okay, so we can go ahead and do this. Now, of course, from that point, it becomes easy to solve for b. So in other words, you have like 2 is equal to 3 plus 3b. Okay, then -1 is equal to 3b, meaning that b is equal to -1 over 3. I'm going to circle this in orange because this is one of our parameters. So we found the necessary value of b. Then, of course, to find the value of a, you're going to substitute that value of b in this equation. So a is equal to twice 1 and then minus 1/3. And the rest is just doing the calculation. So it means that a is twice of 2/3, meaning a is 4/3. All right, I hope this helped. As you can see, I stumbled a little bit during the problem, so it's very important that you understand what you're doing, because otherwise you might stumble without really realizing what's going on, okay? But what saved me during the video is that I knew what I was doing. I knew that I was looking at information that was valid only when x was equal to 1. Okay, and I knew that the slope of this line must match the slope of the tangent line at 1, and I knew also that the y coordinates of these two curves must match at 1. Okay, so that's what allowed me to continue the problem, even though I stumbled like in its organization a little bit. All right, hopefully this helped. See you in class or in the next video.